our practice exam. So the first one says, let f of x equal that function. What is the domain of x? So when you guys are looking at a function, first thing you should always kind of be leery of is a denominator, because your denominator cannot equal 0. So in this case, I would take my denominator and find out what values I cannot have in my denominator. Okay, so I would have 2x cubed cannot equal 0. And then I would start solving this. Divide by 2 cannot equal -8. And then I would take, in order to get x by itself, I would take the cube root of x cubed on both sides to get that x cannot equal -2. So that's one part of my domain that I know is x cannot equal -2. Does anybody else see anything else on here that we should maybe be a little bit leery of?
Maybe the radical.
The radical. What number can you guys take what numbers can you not take a square root of?
Negative.
Negatives. Yes. So what I am going to do is what's underneath my radical has to be greater than or equal to 0. Okay. And we did all this good old inequality work at the beginning of the trimester. And this is not a linear. It is a polynomial. So I'm going to try and factor it. Okay, it's our difference of squares. Take the square root of each one. So I have x to the third. And then the square root of 1 is 1. So I have plus 1, minus 1. And then I would find my zeros. So I would have x cubed plus 1. I would solve that. And then I would have x cubed minus 1 equals 0. So this is x cubed equals -1. And then I would take the cube root. So x is equal to -1. The cube root of -1 is -1. Then I would go ahead and on the other side, add 1. Take the cube root. So x is equal to 1. Now, when we have inequalities, guys, in order to test points, when we have inequalities that are not linear, we have to test our points. So I put these two on a number line, and I test them. They are going to be closed circles based off my interval, my inequality, so closed. And then I would just go ahead and test points. So a number less than -1, I would do -2. -2 cubed would be -8. -8 plus 1 is -7, so it's some negative number. Same thing, -2 cubed is -8. -8 minus 1 is -9, so some negative. A negative times a negative is a positive. Are positives greater than 0? Yes, they are, so true, so I would check. Then I would check 0, 0 is the easiest. That would give me a +1 times a -1. So positive times negative gives me negative. Are negatives greater than 0? No, so I'll leave that one. Then a number bigger than 1 would be 2. If I plug that in, 2 cubed is 8. 8 plus 1 is 9, so positive. 2 cubed is 8. 8 minus 1 is 7, so positive again. So we get positive. And positives are greater than 0, so I would shade. So here's basically the domain of the two different parts, but we need to combine them together. So what I would do is, I would say, well, this is my domain, except for who else do I have to be worried about? Can't be -2. So I'm just going to draw that on here. So I'd have -2, and since it can't be, it'd be an open circle. And then from here, I could find my domain. Interval notation, you guys. It would be -infinity to -2, parenthesis, because it can't be -2, union, -2 to -1, bracket, because I can be -1, union, bracket 1 to infinity. Questions on A? All right, then let's talk about points. Where are they? So, 1 point for identifying the top as an issue. So here would be kind of you identifying that the top's an issue. So that'd be plus 1 point. 2 points for getting x is greater than 1 and x is less than -1. So this part right here gets you 2 points. Then you get 1 point for identifying the denominator as an issue. And then you get 2 points for solving for the issue. And then your final answer, what does that leave for a final answer? The actual answer, right? 1 point plus 1. So how much are we based on work here, you guys? A lot. So it's really important that you write your work and show your work. Questions about points or anything on A? Okay. B. Compute the limit as x approaches infinity of f of x using limit laws, or explain why the limit does not exist. All right, so I'm going to write it. We got a limit as x approaches infinity, x plus. Anytime you guys we have a limit going to infinity, what do we got to try and do? This is our 2.6 stuff. Take the x out. We're going to divide by the highest degree in my denominator. So my highest degree in my denominator is x cubed. Okay, so I'm going to divide everybody else by an x cubed. Now we're going to be careful. Underneath my radical, okay, you would have to say to yourself, the cube root of what is equal to x cubed? That's who you guys need to divide by underneath your radical. So who would you take the cube root of to get x to the third? X to the sixth, yes. Cube root of x to the sixth. This is a little 2, so we take 6 divided by 2. So we divide everybody in here by x to the 6th. Okay, now I'm going to show my work. I'm going to do a little simplifying here. So I got my limit as x approaches infinity of, I'm going to write x cubed, then I got 1 over x squared. I'm going to write out probably one extra step that you guys don't need to, and I'll explain here in a second. And then here, I'm taking out an x cubed, or sorry, x to the 6, which is the same as x cubed, maybe 1, all over. Now here, this part, I would have x cubed, 2 plus. All right. So the goal is to factor out an x cubed and then they'll cancel. So I just want to show you guys that work. This one you got to be careful of because we have that radical. Essentially, when I take the cubed root of x to the 6th, it's really going to be x to the 3rd, but what kind of number does it have to be? It's got to be positive, right? It's got to be a positive number, so when I take it out, this will be positive. So we do absolute value of x cubed. And basically what that does is it plays a role in your final answer, okay? This part right here, since it's a positive infinity, guess what your answer is going to be? Positive. If it was negative, you'd have to be careful, it could be a negative answer, okay? So there's that. And now I can take out an x to the cube for all of these. So I'm going to rewrite one more time. So I have x to the 3rd, and then I have 1 over x squared. Alright, if you wanted to, you guys could go from this step to this step. Okay. So I'm just going to show you how you take that out. Then I'm just factoring out an x cubed from both of those, so I have big parentheses. Then from here, my x cubes will cancel. That's nice. And now anytime you guys have some number over an x, and you're going to infinity, what happens to it? Goes to 0, because it's really 1 divided by a super duper big number. 1 divided by a super big number gets really, really close to 0. So this part will approach 0. As you go to, it gets bigger and bigger, approaches to 0. Same thing here. And then this also approaches 0. Okay, so what do I got? I've essentially plugged in my limit, so I'm not going to write it anymore. So I will have 0 plus the square root of 1 minus 0 all over 2 plus 0. This will give me the square root of 1 is 1. Any questions on that? I know we haven't done any 2.6 homework questions yet, but questions on this? Okay. So this one is kind of like 15 points. I don't love how they do it, but I get it. Okay, so here's how they do the points. Showing this division by x to the 16th. Sorry, x to the 3rd. I don't know why I said the 16th. I would take this, okay, or this version, but that part right there is worth 5 points. Somewhere you guys had to show that you divided out by an x cubed. Dividing out by an x cubed, either this one or this one, will get you your 5 points. Then this is what they say. Plus 8 points, useful algebra. So in my case, or this case, I would say this would be our useful algebra. And then, how many points does that leave us for our good old answer? 2. 2 points for your final answer. So trying to really drive home the fact, a lot of it, you guys, is not just the final answer. It is a lot of work. Questions on my scoring or this problem? All right, good. Number 2 is the thinker. It's a good one. All right, we got our g of x, and we're finding it as our limit goes to infinity. So, just gonna write it out. So our first idea, you guys, when we see we're going to infinity, is to look for the biggest degree in the numerator and divide out, biggest degree in the denominator and divide out by that term. This one's a little different. Why come? It's got your good old sines and cosines in it. So if I divide out by x, I would have sine of x over x. Does that reduce to anything? Or does that help us out? It doesn't help us out. So guess who you need to use on this one? Good old squeeze theorem. And typically, you guys, when we do the squeeze theorem, it's just a sine or a cosine. This one has sine and cosine mixed together. All right, so let's just think about if there was only a sine. Who can you guys typically squeeze sine in between? Who do we squeeze it in between on the notes and the homework? Who do we go from it to? Sine's your y. How far down does your y value go? What's that?
Infinity? No.
Remember sine looks like this? What's the lowest y value?
Usually 1 and 1.
Negative 1 and 1. Negative 1 and 1. So I can squeeze my sine in between negative 1 and 1. Alright, that's usually how we start on our squeeze theorem. Got to be a little bit more careful this time because we have sine and cosine. Okay, who can we go ahead and squeeze cosine in between, you guys? Negative 1 and 1. Same idea here. Now we need to be careful. It's really, you could think about it as sine plus a negative cosine. So I'm going to make this a negative cosine. If I do that, I would multiply everybody by a negative 1. So what do I get? I get 1. I got to flip my sign. And now what I'm going to do is I want to have sine, I'm going to say sine plus a negative cosine. So I'm going to go ahead and write this below here, and in the order it's supposed to be. You guys see how my inequalities are opposite? Let's flip around. So I'll have negative 1. Now, if I were to add these together, I'll see who I can squeeze, sine of x minus cosine of x together. So if I add this, I get negative 2, less than or equal to. Sine plus a negative cosine will just be sine of x minus cosine of x. Less than or equal to. So in this case, you would squeeze it in between negative 2 and 2. Questions about that? Then I'm going to start my proof. Starting it out with this. And when I have the squeeze theorem, our goal is to make the middle part look like the function I was given. Okay, it was sine of x minus cosine of x, and then it was divided by x plus 2. So I'm going to divide everybody by x plus 2. So now I have negative 2 over x plus 2, less than or equal to. And now from here, I have my function g of x in the middle, but now what am I asked to do with my function g of x? Find the limit. So tack the limit on with each one. So we're going to tack our limit on with each one. So we have our limit as x approaches infinity of negative 2 over x plus 2. Sine of x minus cosine of x. And now we can't find the limit of the middle piece. That's why we did the squeeze theorem. So I'm going to find the limit of the ends individually. Okay, they're going to infinity. So whenever I do infinity, I'm going to go ahead and divide everybody by the biggest degree in the denominator. So in this case, it'd be x. So I have my limit as x goes to infinity, dividing everybody by x. So I have negative 2 over x, all over. X over x is 1. Sorry, I didn't show my factoring out piece. Okay, so I got negative 2 over x. Then I took out an x, and I got 1 plus 2 over x. My x's will cancel, so that's nice. And then in this case, I have negative 2 over infinity. What will happen to negative 2 over infinity? Goes to 0. And 2 over x, or 2 over infinity, goes to 0. So I have 0 over 1. What is 0 over 1 going to be? 0. Mine's getting crowded. You guys maybe just go down with yourself one. So there is the left-hand side. So I'm going to do the same thing on the right-hand side. Okay. So I'm going to divide everybody by x. So I got my limit as x approaches infinity of x 2 over x. And what will happen with this result? It'll be the same thing, right? The only thing was everyone's a negative, but that part goes to 0. So this equals 0. So I would have 0, then I have this guy, then I have 0. So I'm going to rewrite it like that. So I got 0 less than or equal to my limit. X approaches infinity. Sine of x minus cosine of x. If we're squeezed in between 0 and 0, you guys, what do we got to be? 0. 0. Therefore, our limit as x approaches infinity of sine of x minus cosine of x, all over x plus 2 equals 0 by the squeeze. questions on the work for this one? Alright, so let's talk about the points. We're 15 total? 15. You get 5 points for getting to this part. -2, squished in between -2 and 2, plus 5. Then you get 5 points by showing your division by x plus 2, so that's 55 and another 5 points. And then, from here, showing your work to get to this conclusion, along with this conclusion, so that gets your last 5 points. Questions? Good. Then we got 2, 3, 3. This one should look similar to our group work we did last time. So use the following: trustworthy and not misleading graphs of the functions f and g of x to solve the problems below. Clearly justify each answer. Okay. So evaluate the limit as x approaches 2 of g of x. Explain why the limit does not exist, or explain why the limit doesn't exist. So in order to make sure a limit exists, you guys always make sure you show your left and right, especially when it comes to a graph. Okay, when it comes to a graph, show your left and right. So I'm going to explain or find it. So I would just say my limit as x approaches 2 from the left of g of x. Okay, so this is f, here's g at 2. My limit from the left hand is going to lead me to the number 1. Remember, limit to the y value. Okay, then we do the right hand side. Limit as x approaches 2 from the right of g of x. So here's 2, here's function g from the right, it approaches 1. So, since those match, you can say left hand limit equals right hand limit. I also do left hand, right hand, that would be fine. Since they equal each other, I can say my limit as x approaches 2 of g of x, the overall limit is equal to 1. Questions on the work for A? Let's talk about our points. 3 points for the left-hand limit. 3 points for the right-hand limit. Those for your finals. Questions on that one? Good. This one. Evaluate the limit of h of x or explain why the limit does not exist. So we're going to do the same thing. So our limit as x approaches 2 from the left, and we're doing f of x times g of x. So you can write h of x right now if you want. I'm just going to skip to f of x. And then I'm going to go ahead and find my limits from the left and the right. So f of x at 2 from the left. Here's f. So from the 2 from the left, we get 1 times my limit as we approach 2 from the left of g would be 1. That gives me 1. Questions on my left? Right? F of x times g of x. So here is my f of x as we approach 2 from the right. We're going -4 times 2 from the right of g of x would be 1. So this gives me -4. So does my limit exist? No. So 2 ways you can show it or explain it. Sometimes I actually write it out like this. Depending on, so if you see it on my key, I'm just going to explain, they both work. So this is saying my left-hand side doesn't equal my right-hand side. That's option 1, you could say that. Or you can literally say left hand, you could write left-hand limit. I also sometimes just do left hand doesn't equal right hand. Those are all 3 equivalent things. Okay. I've also seen before left-hand side doesn't equal right-hand side. Just so you guys are all clear, they mean the same thing. So I would need to see one of those saying they don't equal. So then your overall limit, what's true about it? Doesn't exist. So limit as x approaches 2 of h of x does not exist. With one, usually put one type of clarification. Points on this one's very similar. 3 points, 3 points, and then this with the justification is 2. Questions on B. The multiplication one, you guys gotta be careful, it can exist, remember. What number would have to be involved here so that it would exist? 0, right? Like if this was 0 and this was 0, so if my g of x was a graph like this, this would be 0 and 0, and so then it would exist. It would both approach 0, so the final limit would be 0. Does that make sense? 3. Is h of x continuous at x equals 4, why or why not? Okay, in order for something to be continuous, the definition or the way that you show it is your limit as x approaches -4 of the function, h of x, needs to equal the point. So your limit has to equal the point. Limit equals point. So we're not going to talk about this one at this moment, but do you guys agree, we already did this, for g of x, did our limit as we approach 2, did the limit exist? Yeah, it did, it existed, it was 1. However, am I continuous at 2? No. So if my limit exists, that just confirms that my curve is leading me to a point. It can be open or closed. In order to make sure it's continuous, I need to make sure that it's filled in. This point would need to be up here and closed, right? Then I have no hole in it, so then it is continuous. So you've got to be careful of that. So in order for it to be continuous, you got to have your limit and your point. In order for a limit to exist, you got to check your left and your right. Okay, so we're going to do left, right, and we got to check that point. So, limit as x approaches -4 of h of x, and h of x was defined above, right? Is that what it was from part B? Yeah. Yes, okay. So we got the limit as x approaches 4 from the left, f of x times g of x. We're going to find that. Okay. So here's -4 for our f of x. From the left, we would get -2 times our g of x as we approached -4, 0. So we got 0. Then we got our limit as x approaches -4 from the right. It's f of x times g of x equals. So I do my f of x as we approach -4 from the right. That gives me 1 times g of x from the right as we approach -4. That gives you 0. So right now, does my limit exist? Yes, this tells me my limit exists, so this part works. Okay. So I would just say that these match. Left hand equals right hand, so now I know my limit as x approaches -4 of h of x equals 0. That only confirms to me, you guys, that I have my limit exists. Now I gotta make sure that the hole is filled in. Okay. So then I have to find h of -4. This is our point, which is really equal to f of -4 times g of -4. Just based off the way that h is defined. So f of -4, I'm looking for the closed circle, so I go to f -4, my closed circle is here, which gives me 1, times g of -4. So I go -4 to my line, so it gives 0, which gives me 0. So are all three things equal? So is it continuous? It is. So why or why not? since my limit as x approaches -4 of h of x equals h of -4, h of x is continuous at so that would be showing that it's continuous. Questions on C? Okay, let's talk about points. Color but not used. Okay, doing it from the left-hand side, showing that it's equal to 0, that was 3 points. Doing it from the right-hand side, that's 3 points. Doing the point, that is 3 points, so that's 9 out of your 12. I got one too many points on here. This is supposed to be plus 1. And then this explanation, plus 3. And out of that 3, it's like 1 point for your conclusion, you need to show this part right here. This is specifically of the 3. Questions on 3? All right, last page. Particle moves along a marked horizontal line so that the location on the line at time t is given by h of t. What is the particle's initial location? Should be familiar from your 2.1 worksheet. How do you guys find somebody's initial location? Yeah, initially you start out when your time is equal to 0. That's your initial. So I do h of 0. So I'd have 0 squared plus 5 times 0. -2. This one, knowing that you plug in 0, 3 points. Getting the right answer. Questions on it? Pretty straightforward. All right. The particle moves along a marked horizontal line, so that's location, we already have that. Find the average velocity of the particle during the time interval. You should show your work out. No, you should work your answer out, your answer to a final number. Okay. So when I'm asking you guys for average velocity, what do you gotta be thinking? Old school slope. Okay, old school slope. Whenever I say average, so it's y2 minus y1 over x2 minus x1. However, in calculus, we don't use y2 minus y1, we use function notation. So we use f of. Are we using a function f of this time though? We're using a function of. We're using function h. So our average velocity, we would have h of, and then it's our value to plug in 3. Minus h of 1 all over 3 minus 1. And then we just go up to the side and find h of 3. So I have 3 squared plus 5 times 3. So we got 9 plus 15, 24, 24 minus, so I get 22. Find h of 1. 1 squared plus 5 times 1 minus 2. So I'd have 1 plus 5 is 6. 6 minus 2 gives me 4. I would then plug that information into here. So I got 22 minus 4 all over 3 minus 1, so 2. So I get 18 over 2, which gives me 9. Let's talk about labels. Okay, you should always label. Some years they're hit or miss about whether they give you points or not for labels. Sometimes I'm like, really? Like, this is the, like, last year I think they didn't give any points for labels until the 3rd exam. So just always put them on. It just depends on who had the U, I don't know, it's supposed to be the same, it's always the same person, I just think they changed their mind. So always label. Okay, so this one, you plug in time. Do they give us any form of time? No? Okay. Just so you guys know, if there was labels on here, let's talk about, let's say we're seconds. So our time is seconds. This label down here, 3 and 1, those are representing seconds. Okay? H of 3, H of 1, that is telling us the distance that they traveled. So they didn't tell us meters or feet or anything, let's just use units. So these represent how far the particles traveled, so units. So the way you guys get the label is it would be units per second. That's how you label it. So always you can go back to your slope formula and be like, it's your y value or your x value. So what's the label on your y, what's the label on your x? Questions on B. Okay, points. You're set up. Six points. And your answer. +4. Questions on B. Alright, last guy. Set of a limit that represents the instantaneous velocity. So you guys, if I'm talking about instantaneous, I'm talking about at 1 second. Okay? However, we don't know how to do this with just 1 point, so we kind of make up a second one strategically, so it's not made up. So if we're doing it at 3, we always do our other point will be t equals 3 plus who? Who was the variable we did? Plus h. Yes. So use a limit whenever we do instantaneous. It says then use a limit to compute. So we do our limit, and our limit is then who approaches what? H approaches 0. The reason it's h approaches 0, if I plug in 0 right here, you guys, what's 3 plus 0? 3. So I'm going from t equals 3 to 3. If I go from 3 to 3, am I at 1 instant? Yeah, I'm at the instant of time equals 3. Okay, so that's why you do the limit as h approaches 0. Okay? And then we just use our slope formula, with these being our 2 times. So it'd be h of 3 plus h minus h of our other value, 3, all over 3 plus h. And I think I've said this to you guys before, if you want, you can always just make the denominator h, you can write it out with your points. And you can see that's your slope formula. Then I would go off to the side and I would find h of 3 plus h. Lots of h's going on here. So we're plugging in 3 plus h for any t in this equation here. So we would have 3 plus h squared plus 5 plus h minus 2. 3 plus h, you must write it twice and FOIL it. Okay, so I'm just going to write what it would be. It'd be 9 plus 6h plus h squared. Distribute our 5, so plus 15 plus 5h minus 2. And then I'm just going to combine my like terms. So I have h squared plus 11h. 9 and 15 plus 22 minus 2. So it's my f of 3 plus h. Sorry, not f of, it's h of 3 plus h. And then I have to find h of 3, but always try and think smarter, not harder. Did we already find h of 3? We did on the previous page, or previous problem. Was it had to be by 22? Okay. So I'm going to go back and continue doing my work. I can't plug in my limit as h approaches 0 yet, so I got to keep writing it. So then I would do f of 3 plus h. So I have h squared minus 22 all over h. My 22s won't cancel. Yes, things should cancel nicely. If they didn't, you made a mistake. Go back and look it over, okay? Then I would have my limit as h approaches 0. Factor out my h. Cancel those h's out. And now, can I plug in 0? I can. Plug in 0 for each line. 0 plus 11, which is 11. And then it would be the same idea. I had y values, which gives me out my units over my time. So units per 10 seconds. So when you guys find instantaneous velocity, it's like you're driving down the road on your car and you turn and you look, or you turn and look. You look down at your speedometer, that's your instantaneous velocity. How fast are you going at that second? So how fast is this particle going at that moment? 11 units per second. On average, from 0 to 3 seconds, no, from 1 to 3 seconds, he did 9 units per second. So here's gonna average it out. Check that. Let's talk about our 20 points and how we earn them. Either one of these, doesn't need to be both. Either one is 5 points. So write down one or the other, that's 5. Then showing out this work right, sorry, I lied. I got too carried away. This one's 5. The other comparable would be to have this written with just H on the bottom. Okay, that'll get you 5 points. Then this is another 5, having this plugged in, I didn't see that. That's 5. And then show some algebra, so plus 5 points for algebra. I'll do this part right here. And then plus 3 points for showing that cancels out H. Cancels out H, which leaves us 2 points for our final answer. Right? Yes. So there is 4C. Questions on 4C?